Hi everyone. Today we will be discussing a question regarding on simulation and credibility theory. The module code is Act60204. And here comes some group members Chow and Yugan. So now both of us will be discussing question 2 of the computer based test. So this is question 2. You are given the following information about a group of policies. First, the IF claim amount is denoted by XI. Claim amounts can be 300, 350, or 500. Second, the claim amount is dependent on the value of a risk parameter data. Third, data is a random variable that takes the value data 1 with probability y plus 0.05, data 2 with probability y plus 0.04, value data 3 with probability y, data 4 with probability x, value data 5 with probability 0.23, and data 6 with probability 0.06. The fourth piece of information gives us all the information about x given data. Fifth, the random variables xi given data are conditionally independent. And we are given the Bayesian premium equation, which is the expected value of the 7 claim given S1 equal to 300, S2 equal to 350, S3 equal to 500, S4 equal to 300, S5 equal to 300, S6 equal to 300 equal to 389.9672107. And they want us to find x and y value. First of all, the first step is we use all the x and data information given by the question to make a table. Step 2, make a table of probabilities of data 1 up to 6. And let probability of data 3 be an unknown y with a null value cell. And let probability data 4 equal to 1 minus probability data 1 minus probability data 2 until probability data 6. Because the total probability of data should be equal to 1. And we keep y and x cells blank. We will use solver to find the x and y value. Now pass to Chow do the further explain about step 3 and the application.
To solve this question, we must first calculate the value of each component. The first equation to find will be the expected of x given theta for each data from 1 up to 6. We make use of the value keyed into the Excel spreadsheet to form the formula. For example, to calculate the expected of x given theta 1 would be to multiply all the x value with their corresponding probability under theta 1, which would bring us to the first equation. So for the expected of x given theta 1, it will be 300 times 0.3 plus 350 times 0.3 plus 500 times 0.4, which will end up giving us 395. We then continue to apply the formula for the remaining expected of x given theta 2 up to theta 6. Next, we try to find the probability of x1, x2 up to x6 given theta. The formula will require us to multiply all the probability of x1 given theta up to x6 given theta. Since the question has mentioned the value of x1 up to x6 being 300, 350, 500, 300, 300, and 300 respectively, we can generate the value of probability of x1, x2 up to x6 given theta 1 by multiplying the x value probability given theta 1. We then proceed to do the same for the remaining equations. Then, the second component is to find the probability of data given x1 up to x6. Therefore, we must piece together the equation that forms it. To begin, we can combine the values we got from the previous slide by multiplying them with the respective probability of data. Our results will currently give us some value with unknowns since the x and y has yet to be found. Then, we sum up all the products which includes the unknowns, and that will give us the overall probability of x1 to x6. Finally, the last step would require the Excel solver add-in function to help solve the simultaneous equations formed just now to give us the value of the unknowns we are looking for. To use the solver add-in, we must key in manually the Bayesian formula in an Excel cell by using the results of the equations we have done previously. Then, we pull up the solver tab and set the objective to the cell containing the formula. Next, we select the cell chosen to become a value of 389.9672107 as provided in the question. Then, to find the unknown in the equation, we set by changing variable cells to the cell we assume as the unknown y. By clicking solve, the solver will automatically run and provide us with the results. After solving, the y will be 0.2 and the x will be 0.02 after subbing in the known y value. That is all for this question. Thank you very much.